Hi everyone, I welcome back you all to my next presentation. Today I am here to deal with the subject Mathematics 2 for CSE stream, which has the subject code BMATS201 related to the topic Center of Gravity. As you all know, I am Chitrashriyam. My USN is 1VE23CS042. Currently pursuing my BE in Sri Venkateswara College of Engineering in the Department of Computer Science and Engineering from second semester. For the one who is watching this video, I would request you to drop a like for this video and please continue watching at least for 4 minutes so that it will help to fetch my internal marks. Initially, the introduction to center of gravity. The center of gravity is one of the fundamental concepts in mathematics and even as well as in the physics, representing the point at which an object's weight is evenly distributed. Understanding this crucial point helps us to analyze the stability and balance of various systems from mechanical structure to the fluid dynamics. Definition of center of gravity. The center of gravity is usually denoted by the letter G or CG. It is the point at which an object's entire weight can be considered to be concentrated, or it can also be defined as it is the average location of the weight of an object determined by the distribution of mass within the object. Moving next, importance of center of gravity in the field of mathematics. There are mainly three reasons or three importance of center of gravity. They are stability analysis, optimization and dynamics. In stability analysis, the center of gravity is crucial in determining the stability of an object or the system as it affects the force acting on it and its potential for tipping or toppling. In optimization, calculating the center of gravity helps in the design and optimization of structures, machines, and other systems to ensure they are balanced and they are efficient. In dynamics, the center of gravity is a key factor in understanding the motion and dynamics of objects, such as the behavior of a pendulum or the trajectory of the projectile. Calculating center of gravity for simple shapes. Rectangular shapes, triangular shapes, and circular shapes are the best examples for simple shapes. So there are some ways for the calculation of center of gravity for these shapes. For a rectangle, the center of gravity is located at the intersection of the diagonals, which is the geometric center of that particular shape. For triangular shapes, the center of gravity of a triangle is located at the intersection of the three median lines which connect each vertex to the midpoint of the opposite side. For a circle or for a sphere, the center of gravity is located at the geometric center which coincides with the center of mass. We are done with calculation of center of gravity for simpler shapes. Now calculating center of gravity for complex shapes. There are three more ways from which the center of gravity for the complex shapes can be calculated. They are decomposition, centroid calculation and weighted average. In the process of decomposition, break down the complex shapes into simpler or well-defined shapes such as rectangles, triangles or circles which are nothing but simpler shapes. In the process of centroid calculation, calculate the center of gravity for each component shape using the methods from the previous section. Weighted average. In this process, determine the overall center of gravity by calculating the average of the individual component centers using the mass or area of each component by considering it as a weight. There should be some applications. So the applications of center of gravity in the field of engineering as well as in the field of physics, they are structural design, vehicle dynamics, aerospace engineering, and at last the fluid mechanics. When it comes to the structural design, analyzing the center of gravity is crucial in the design of stable and balanced structures such as buildings, bridges, and towers. In vehicle dynamics, the center of gravity affects the handling and stability of vehicles, influencing factors like cornering, rollover, and load distribution. When it comes to the aerospace engineering, in aerospace engineering, the center of gravity is a key consideration in the design and control of aircrafts, rockets, and spacecraft. At last, the fluid mechanics. The center of gravity plays a role in the analysis of buoyancy, stability, and the behavior of objects which are submerged in or floating on fluids. Factors affecting center of gravity. There are mainly four factors which affect the center of gravity. They are mass distribution, geometry, orientation, and deformation. In mass distribution, the way the mass is distributed within an object or system significantly affects the location of its center of gravity. Geometry. The shape and dimensions of an object influence the position of its center of gravity as it depends on the distribution of mass. Orientation. The orientation of an object can shift the position of its center of gravity, which is crucial in applications like construction and transportation. Deformation. Elastic or plastic deformation of an object can cause a change in the location of its center of gravity, impacting its stability and its behavior. So finally, the conclusion and key takeaways, which means I can summarize this whole presentation or this whole topic of center of gravity in three terms. They are fundamental concept, stability analysis, and optimization and design. I already said the center of gravity is a fundamental concept which is used in both mathematics and in the field of physics, with its applications in various fields, including engineering and even in the field of fluid mechanics. Stability analysis. Understanding the center of gravity is crucial for analyzing the stability and balance of objects, even the systems and even the structures. At last, the optimization and design. Calculating the center of gravity helps in the design and optimization of systems and structures to ensure they are balanced and they are efficient. Thank you for watching my video.